permission for anyone to record this locally.
Okay, great. I am just
Okay.
sharing the YouTube link in the meeting chat. So you can just share this link with your teammates and you can ask them to join this link. All right, I have already pasted it in the chat window. So you can make use of the link. The stream has already started. Professor Pant, over to you.
Okay. So welcome to the fourth webinar of NACDeC-VIII, which is on the conceptual design and sizing of a supersonic unmanned combat aerial vehicle, abbreviated as SUCAV. We would like to start by giving you a generic feedback on the midterm reports. Okay, Pranav, do you want to take over and go through this list?
Sure, I would like to. So, right. The feedback of the midterm report can be summarized on the screen. They have been classified into some major headings. The first heading that I would like to talk about is no justification. Right. So when we were going through your design reports, we found that there are no justifications for configuration that you have selected. Many teams have gone for, a design of a delta wing, but there is no justification. Why does that make sense for your design? What is your design thinking? I would just like to explain to you that whenever you are doing any problem on aircraft design, any report should be like a coherent story. Everything should make sense, right? So one part of the story is what we have given you. That is the mission requirements, the mission profile. The next part of the story is something that you have to create yourself, right? When you are giving parameters, when you're selecting configuration, we request that you provide suitable justification, because without justification it does not simply make sense to us. It might that to us, we have no way of authenticating it. Okay, so that is point number one. Point number two, when you are selecting your design and propulsion parameters, you have many teams have just simply said that wingspan would be so and so, like x meters, chord will be so and so, x centimeters or meters. This would be the aspect ratio. From where are you getting those numbers? Is there any logical justification to them, right? Because I could simply say that my aircraft would be 10 meters long. Fine. But what is the rationale behind it? Is it a good design or not? So, those links are really missing. And currently we are at that stage in the competition where all these parameters have to be selected very carefully and a proper justification for the same has to be provided, right? If you have taken something from the literature, let's say you have read about 10-15 papers and you have summarized the table, then you could say that based on a literature review study, we have seen the vehicle wingspan is between 5 and 7 meters. Just to give an example, for a payload carrying capacity of, let's say, 200 grams, 300 grams, whatever, that number can vary. For your third part, the mission profile segments, right? We have given you a mission profile, but it is up to you how much time are you going to spend for each segment of the mission profile. So please come back. Please come back
Now your voice seems
to
to
previous
be
slide itself.
fading away.
So this is
Your
what is
voice is
to
fading away,
expect.
Pranav.
Go back to the previous slide, please.
I
Slide
just
number
said
2.
your voice faded last few minutes. Last one half a minute, your voice was fading. But anyway, people can read what you said, so no need to really worry. Let's go to the next slide.
Right. Again, it seems that you are not following any methodology, any sequence, right? All your decisions seem arbitrary in nature. So there is no methodology. This is something I'm going to talk about as well ahead. So understanding of the problem statement also seems to be a bit dicey from your end. You need to really emphasize what is the challenges in the design. And majority of the teams have not made use of something that is called the vehicle performance score. A objective function has been provided to you and you are required to maximize it to the best of your capability. But we saw none of the teams or majority of the teams have not done it. So that is something we want to emphasize on. Many teams are deviating from the problem statement. They are going into unnecessary things. They are going into operational requirements. You are not required to study from which airport is it going to take off or which, how much, what will be, which runway will it require. Not your concern. Your concern is this is the runway length.
Pranav, I'm sorry, I'm not able to hear you. Can somebody else please give a thumbs up if you are able to hear Pranav?
No, sir, we can't hear him.
Yeah, we can. I also can't hear him. Pranav, if you can hear us, please note we cannot hear you. Perhaps there is some issue at his end. So
Is
let
it
me
better
just,
now?
yeah, it is better now. So please repeat. You went to the vehicle performance score. After that, we could not hear you.
Right. So as I was mentioning about the vehicle performance score, Professor, just interrupt me when my voice is not better. I'll join from another device, if that is the case. Okay. So we found that students have to really delve into something this is called the vehicle performance score. That parameter has been given to you in the problem statement. You have to maximize it to the best of your ability. Okay. From that, you have to go ahead. Another point is deviating from the problem statement. Many team members are deviating from the problem statements. You are looking at indirect and direct operating expenses. It is important, but not a matter of concern for this competition. All right. You don't have to look at which airport is it going to fly from. You just have to see this is the takeoff and landing distance. You have to think like a designer right now. I get that it is important, but not it is not in the purview of the competition. And last point, the wow factor is missing from majority of the submissions. Right? We are not really convinced. We are not really feeling the design that you have submitted. It feels like okay, you have done some work. It's all right, but that that when I read a report, it should really stand out and it should look like, yes, these students have run a really good job. And my final comment is in depth analysis is required, really required. Currently, one of our team members is going to speak about analysis in this webinar itself. Please go ahead, sir.
Okay. All right. So I would like to take over here. Basically, when we do aircraft conceptual design, let me just put my video on just a minute. When we do aircraft conceptual design, which is what you are doing, it is very important for you to follow a well-defined methodology or well-defined procedure. This procedure has to be structured and it should be formal. It should not be arbitrary. And this is obtained by a study of textbooks and literature related to aircraft design. The methodology that you follow should encompass all the models that you are going to require. You may even go beyond aerodynamics, propulsion structures. You may look into some stability issues. Some of you might worry about stealth issues. Okay, all those models have to be considered. This is very important because with a methodology that is clear cut and focused to the design problem, you will immediately be able to identify any risk in the design process if some configuration or some particular candidate is not going to really maximize your performance score, vehicle performance score, then those aspects can be ignored right in the beginning. Otherwise, you will be wasting a lot of time. A methodology also allows you to do iterative testing and refinement, which will be required as you go ahead. Okay. If you have a proper method, then your design can be considered to be more authentic and it will be easier to validate that for a, if you have, for example, solution to a problem and you can run your methodology for that particular requirements and try to get the numbers. And also, if you have a methodology, it becomes easy for team members to have a proper communication. So therefore, we are very particular that if we get design reports which do not follow any formal methodology and which is haphazard. It looks like someone did aerodynamics arbitrarily, someone did structures arbitrarily, and you just put the things together and submitted the report. That design is going to be summarily rejected. Okay, so we need a methodology and it has to be formal. So moving ahead, there is something called as a design framework. For example, you will require to estimate what is the energy that you need in this aircraft. You will then combine that with aerodynamics and mass and propulsion. So it is very important. And with all this working together, you get the final design. If you work in isolation, as I said few minutes ago, sometimes while dividing the work in the various team members, you end up saying that we will cut the problem into 5 parts and we will give every member one part. And then you work independently on that part and bring it together. That doesn't happen. Design will be successful only if there is a constant iteration between various team members. Okay. Right. Now, when we look at aircraft conceptual design, one of the stalwarts of design is Daniel Raymer. He has given these 6 parameters which kind of capture the essence of the aircraft. Of these, because the wing is the main component that produces lift, and therefore there are 4 important parameters: thickness to chord ratio, also called as thickness ratio, the taper ratio, the sweep, and the aspect ratio. These are the 4 parameters which out of them 3 are dimensionless. The thickness, the taper, and the aspect ratio are dimensionless. Sweep has a number value which is in radians or in degrees. Other than that, there are 2 parameters which are related to the aircraft, which is the wing loading, that is the total gross weight of the aircraft divided by the wing reference area, and thrust to weight ratio. In our case, I don't think we are able to fly supersonic with a power plant that works on power. So it will probably be only thrust to weight ratio in our case. But in some examples, power to weight ratio might be useful. So for you, it will be thrust to weight ratio and wing loading, and these 4 parameters plus many more parameters that you would like to bring in. But these should be there. Apart from this, you can have more parameters, but these should be there. Okay. Now, why we have talked about these 2 parameters related to the aircraft, W by S and T by W? Because they appear in many performance equations and you have constraints. You have constraints on takeoff distance, landing distance. You have a constraint that the Mach number has to be supersonic. You have a constraint that the total mission time should be less than 2 hours. Okay. And you have a constraint on range. So therefore, when you look at W by S and T by W, this occurs in many of these parameters. Some of them you may not be worried. For example, we have not given you any sustained turn rate requirement, nor we have given you any climb requirement. Okay, it is inherent. Similarly, if you look at only wing loading, it will come into these important parameters which are usually required. Landing distance is an important parameter for you. So that is why it is important that we look at the correct value of W by S and T by W for the design. And then T by W also comes as an independent parameter in some requirements, which again may not be directly relevant to you in this case. Okay. Now, the most important and the most rigorous aspect of aircraft conceptual design after the initial sizing is the constraint analysis. In constraint analysis, normally there are many constraint diagrams, but generally the one that we follow is one which has a thrust at sea level divided by the takeoff gross weight. And this thrust is the maximum thrust available from all the engines put together. And on the x-axis, we have the total aircraft gross weight divided by the wing reference area. So in this particular landscape of T by W and W by S, we plot all the constraint lines as shown in these green and black and vertical lines. And then there is an area that comes a solution space. In this case, there is the upper limit on T by W. So the solution that you finally choose has to be in the solution space. This is done through the process of constraint analysis. Okay. With this, I would like you to first ask any queries that you have. But before that, I think we will request our volunteer member Akriti to share her presentation. So Akriti, over to you. Sorry, Akriti, over to you. You can take over now.
Okay, sure, sir. Thank you, sir. Good evening, everyone. My name is Akriti. I am one of the volunteer member of NACDeC-VIII, and I would like to share upon two most important aspects as you are approaching your final report. So I would like to share some of my views on where actually you should work on and some insights on, maybe your software analysis, how the validation is being done. So, Pranav, if you could share the slides.
Yes, sure. I will just share your PPT. Just
The questions related to workshop, etc., can be asked later. Right now, let us just listen to what Akriti has to say.
sir, could you please make me the co-host as the participant sharing is disabled? Yes, now I have controls. Thank you for that. Yes. Yes, I think my screen should be visible.
Yes, your screen is visible.
Right, I'll just hide the floating controls. Please go ahead, Akriti.
Thank you, Pranav. So, the one of the thing that most of you have been missing in your midterm report, as Pranav and Professor Pant have already told about, is looking into the validation part. Now, how do we validate whatever parameter we are getting is right or not? So, like, you cannot claim that, 48 hours of endurance without justification. That how did you arrive to that value? That seems to be a bit unpractical, but might be you might get this value, but you have to show that with this formulation, or how you actually arrived with that. So that is where the methodology comes. That is where validating some stuff comes. Now, while you're making any assumption, it is really important that you know that what are the physical laws, or what are the formulations that you use, and some past research papers that can be used, and the cited papers are really important to firm your whatever assumptions you are taking. So, if you see on your left hand side, there is one of the NASA's research paper on supersonic airplane study and design, which you could look into. Or be cautious, like while you're looking into the research paper, you only look into the trusted one. Like there are a lot of conferences that happens, and there are conferences wherein you publish the result, but there is no validation or there is no review and all with that. So don't cite papers which you think that are not the authorized conference papers. So some of them I have listed: IEEE, AIAA, Springer, Science Direct. These are some of the trusted source from where you can look into the papers, the research papers related to your topic, supersonic aircraft, and then you can claim the values and all. So also, if you take some faulty assumption, that will lead to a misleading results and impractical values, which will actually affect your final term report. So make sure of that. And how it can be done is the software analysis and the literature review. Next slide. So yeah, so this is one of the literature review for some of the supersonic aircraft, which can be used for the validation purpose. So I'll give you one example. Say, for example, you got some parameter of range. Now you want to see that whether the range that I'm getting is kind of practical or not. So what you will do, you'll look into the literature review, the all the research paper that is there related to the supersonic aircraft that you got. You look into the values, and if the values are comparable, then you can definitely be certain about that, yes, the value that I'm getting for the range value is somewhat correct. But make sure that you don't use these values blindly. These are just for the validation purpose, that whatever formulation that you're using, whether you're going in the right direction or not. And one pro tip from my side will be you can use linear regression model, wherein you can take all those aircrafts and you can just build upon how your how is the trend of the maybe the mass weight or the range, and that will really help you out to figure out that whether the value that you're getting is correct or not. Next slide. So this was all about the validation part, like how you'll justify whatever answers you are getting. Now, the second part that you'll be working in this final term report will be the software analysis part. Now, just to give a glance about why it is important as an engineer, since you are working on this very important and very good project, and it's really important that you look into the parameters that you are getting, whether they are correct or not, and to understand how this how your aircraft is behaving. So for that purpose we use the software analysis. So just as you can see, maybe for making an informed decision that whether the value you are getting or not, as it was being mentioned by Pansa, that this is an iterative process. So if you find something that during the software analysis you're not getting the values that are desired, then you can definitely go back to your drawing table and look into that what are the tweakings or what are the assumptions that are to be mitigated and all that stuff. And it really helps in trade study, validating whether whether the aircraft that you have designed is feasible or not. Getting some impractical values will lead to disqualification from the competition and might not look good as well. And it'll really help you to predict the performance. And the software analysis, one of the beneficial part is that it consider some non-linear stuff as well. Like in manual calculation, there are a lot of linear equations that are being used, or a lot of assumptions that are being used. So when you go into a software, you make somewhat things easy to understand when it is in a non-linear environment, whether your system is working correctly or not. Next slide. So I'll give you a brief on, what all software analysis is vital for any aircraft that you're designing. So the first one comes up is the aerodynamic analysis. So as you know that we have various aerodynamic parameters such as lift, drag, CLCD, wave drag, as you might have done, and some stability derivatives which you can calculate. So for that purpose, whatever CLCD that you have calculated, to understand that whether it is working good for your particular aircraft, is really important to do the aerodynamic analysis. So as you can see in the picture, you can observe that by the rotation of the propeller, how the vortices are being performed and how it is affecting the other aircraft components. So the tools that you can use are the ANSYS Fluent, XFoil, and OpenFOAM. And in the bonus point, we get to know that with some total drag breakdown, maybe you'll be able to get with the help of the analysis and getting the trend of CL versus angle of attack, that whether the airfoil that you have used is properly working or not. So all this is being covered in the aerodynamic analysis. The next comes is the structural analysis. So say for example, you create a wing and you do not know that how much deflection will the wing will be having while it is there in the cruise condition. So for that purpose, it is really important that you understand how whatever the sizing you have done, whether it is correct or not. You have sized your spars, you have sized your wing, you have sized your fuselage in order to validate that whether it is able to maintain that amount of stress. For that purpose, you do the structure analysis part. And the tools that is most commonly used is the SolidWorks simulation. And with the help of Excel, you can just plug in the formulas, and you can give input to the parameters, and finally you can get the results. So in that way also, Excel is very handy. So even if you are not using Excel for now, I'll suggest that you start using Excel or MATLAB for calculation purposes, because while you're working in the iterative part, say for example, you get to know that okay, this parameter is something that needs to be changed. Now if you go with the hand calculation part, you have to do everything step by step on your own, and there are tendency of getting the calculation error. So it is very highly suggested that you use some software. As an engineer, use some software like Excel or MATLAB for the calculation. So this was just a side part. Now, coming back to the structure analysis part, so it'll, as I said, that it'll help you for the stress distribution and whatever material that you're choosing, whether it is able to sustain on the aircraft or not. So you'll definitely get a very good feel into that. Yes, you are going in the right direction or you're not going in the right direction. Next slide. Okay, so coming to the stability analysis part. Now, why stability is important? You created an aircraft. Now you want to understand that if you leave your aircraft, pilot is having some controls with it. So when it is there, in the cruise condition, whether will it be able to stabilize or not? There might be, that CG might be somewhere front, your aircraft might topple and all. So in order to understand beforehand that whether your aircraft will be able to be in an equilibrium condition or not, you use the stability analysis to understand how pitch your roll is being behaving and designing the control surfaces. For that purpose also, stability analysis is very handy. And the tools that you can use is MATLAB and Simulink and XFLR5 as well. But XFLR5 has one limitation, that it works for only low Renault number. So since you are working on a supersonic aircraft, my suggestion will be to not use XFLR5 for supersonic aircraft case, right? And as you can see in the bonus point, there is one CM versus angle of attack. So this actually helps you to understand that whether your aircraft will be stable in the longitudinal direction or not. It's around the fuselage length, whether it will be stable or not, which is very important so that it doesn't happen that it pushes down and goes down. And the fourth part that we have is the sensitivity analysis. Now, what is sensitivity analysis? You would have calculated various performance parameters such as endurance, range, payload mass, total mass. So now you want to understand that how these parameters are related to each other. Like say for example, when you're increasing your like say for example, you're increasing your payload mass, how will it affect the endurance? How much will be the trend? Whether the trend will be linear, linearly decreasing or parabolically decreasing. To understand that part, you do the sensitivity analysis. And doing the sensitivity analysis is very easy. You take the formulation, you look into the payload mass and then look into the endurance, say for example, and then you get a plot according to that. And the tools you can use is Excel and MATLAB, and maybe some hand calculation can also be done. Next slide. So this I'm highlighting some of the common tools that you can use. If not you're using, you can use these tools for the analysis purpose. Now, first, you would have heard about OpenVSP or you might have used it till now. So it have a very good, estimate of, it really helps in the parametric modeling, and you can export the mesh from CFD and you can do this just basic error estimation, and it really helps you to simply calculate the CG and moment of inertia. So you can just plug in your materials, for each component, and then you can get the CG and moment of inertia, and it gives a good fair amount of good estimation for the CG and moment of inertia. And it's really used really best, if you are just initially looking into, how your aircraft will be behaving. So for that purpose, OpenVSP is really good. If you want to go a bit more advanced, you can use SolidWorks, because there for each and every component you create the detail modeling of your aircraft, and then there is a mass property tool which you can use for mass distribution and the center of gravity estimation. And finally, with the help of inertia matrix, you'll be able to understand how the moment of inertia is being distributed all over your aircraft. And it's not just limited to SolidWorks. There are other CAD software as well, such as CATIA is there. So such type of tools are really helpful in these purposes. Then we have ANSYS Fluent, majorly which is being used for CFD analysis. So you get some good accurate CLCD pressure contours. You can look into how the stress distribution is happening. If there is, how the deflection is being happening all over the aircraft. So for that purpose, ANSYS is very easy and very handy to understand. You can just create your own aircraft based on the geometric parameters finally, you can get all those parameters. Next slide. So finally, there are some points that you should remember while you're doing this analysis part. First part is that validate your mesh. What do I mean by mesh is that on your aircraft you create some small you divide your aircraft into small parts such and that is that actually creates a mesh. So you should validate the mesh that whether you have done it right or not. And second thing will be that don't blindly trust the values that you're getting in the software analysis, because the way software are being designed are might be very different from what you thought about that particular formulation. So just don't blindly trust that whether the whatever the formula whether the whatever parameters are coming that are only the parameters. Just validate it the way that I told in the first part. Second is, the parameters that are related to supersonic drag, don't forget to take it into consideration, because there are a lot of drag that is being added in a supersonic aircraft, which is very, very important. And as I said earlier, XFOIL and XFLR5 are for low Reynolds numbers. So you can just use it for some 2D airfoil comparison in the subsonic flow. And mass distribution is really important, while you are completing your final term report. Take care of the mass distribution. And also important point will be that teams are encouraged to explore more on the analysis part. So I just discussed about core analysis. There are propulsion analysis, thermal analysis, mass and CG analysis. So these kind of analysis are also there. Now it depends on you and your creativity and your team's creativity, how you come up with what kind of analysis is required for your aircraft. And most important thing is, you're by my experience, I'll definitely say you're working on a really good project. This will really help you in a long term career. And have fun, just try to tweak in values, look into put some values in the software, check that whether it is coming right or not. So some hit and trial stuff. You'll really have a lot of fun, while coming to a technical conclusion. So that is the important point I would like to emphasize is have fun while working on this project, because you're really working on a very good project. Next slide. So thank you everyone, and all the best. Over to you, Pranav.
Okay, thank you so much, Akriti. That was really, really insightful. I hope that our participants got some idea on the way forward for analysis, right? Before we open the floor for questions and answers, I would just like to quickly mention the upcoming deadlines. I don't have it on the presentation, but you have your final design report submission coming up on 25th of June. After that, all the shortlisted all the teams will be called for a team Viva, because it is very important that we get to know what do you understand and what you have written. Is there any coherence between that, right? So that will be conducted. And after that, based on the Viva, some modifications or some comments will be given to the team members. And we would be expecting all the shortlisted teams to submit a modified report. And based on the modified report, we will be shortlisting 5 teams, which will be coming for the final round of the competition. All right. I hope there is no questions with regards to the schedule. If there is, we can take that up as well. Now, guys, the floor is open for questions. I request you guys to please raise your hand so that I could, pinpoint and ask you guys to unmute and then speak. It would be a good idea, Akriti, if you can also turn on your cam. I think 3 of us can take questions. We can redirect it to whoever is answering that questions. So yes, guys, floor is open. You can please raise your hand and ask us questions. From our side, we are done. And now we can take questions. All right, Team Aero Indians has the first question. Please unmute yourself and ask your question.
Good evening, sir.
Go ahead, good evening.
First question was regarding which software to use for CG estimation, and it was already cleared. So I'll directly go to my second question. Actually, we are facing a lot of problem in doing the fuselage sizing. We all know the Bitcoms area rule, right? like the fuselage should be shaped like a bullet when wings are wrapped around it in the waist. So I don't know how to do that exactly, or how to, like, what methodology to use. So we are stuck in that. And one more question is there, like, I have heard from my seniors and peers that the aerodynamic estimations through OpenVSP, which are done using the VSP arrow, they are a little bit wrong, and there is a lot of problem in that. So I want to know to what extent that is correct, and which one we should prefer. Because when making the geometry in SolidWorks, we are facing a lot of problems in that. So if we get a workshop for that, that would also be a plus point.
Okay. So, Professor, would you
So,
like to take this or should I take this?
yes. So, first question to answer is which software to use for area ruling. The answer is it doesn't need any software. What you need to do is you need to just ensure that the rate of change of cross-sectional area as you go from the nose to the tail is not very rapid at any place. So that can come from a pure geometrical analysis. What you do is you locate your wing, and when you do the bottlenecking of the fuselage, you ensure that if you plot the variation of the cross-sectional area in the direction of flight or perpendicular to the flight direction, if that variation comes reasonably smooth, you will have lower value of the transonic drag. So there is no software for this. It is just a simple geometrical analysis. The second question was regarding the Open VSP and VSP Aero. So VSP Aero software has been used by many people, but I am not personally aware of anyone who has used it for supersonic aircraft design with that much of confidence. So what you say is right. Your conjecture or whatever your seniors have told you, information regarding VSP Aero is limited, and we must confess that we also have not really extensively used VSP Aero, because most students who work on supersonic aircraft, they quickly graduate to ANSYS or some other aerodynamic software, CFX or ANSYS or any other software. So we are not here to promote any software. We are champions of open source software. So we would recommend you to use OpenFOAM for all your aerodynamic analysis work. And we believe there are OpenFOAM is operated by FOSSI, and if you have any issue regarding supersonic aircraft analysis in OpenFOAM, you could actually contact FOSSI to come and do a workshop in your institute. They are the ones who normally go out and promote their software and help the students. And I will also try to talk to the people in FOSSI. Okay, but I don't promise anything because I don't run that program, so I don't know. Okay, it is a challenging problem, but my suggestion to you is I actually believe more into simple classical estimation techniques first to get a ballpark value, and then you can apply all these exotic methods to get, because see, solutions are going to be very much dependent upon the assumptions that you make, the kind of grid that you make. It becomes very involved. So we don't recommend in a conceptual design stage right now. See, to go in an aircraft industry, of course, there are dedicated teams, experts in CFD, so they do all these things. But at a college level, with only 5 people working on so many things along with NACDeC, it may be very difficult, although not impossible, uh, to use something like ANSYS Fluent to run the simulation on the wing at least, or in the wing fuselage junction. But you can try your best, and we will try to revert back to you with some suggestions on this. Okay,
Okay,
so I
sir.
think those were the questions which were asked by Amanpreet. If there is anything I have left out, then maybe we can go ahead. And the floor is
Right.
open for anybody else
I
now.
would just like to add one thing to the Aero Indians questions. So all these softwares like XFLR5, OpenVSP, especially the VSP Aero part, the simulation capability is very limited. It is very good to give you some baseline numbers, but that might not be very accurate, especially for the supersonic case. These softwares are very good for low Reynolds number calculations. Here, that is not the case because we are talking supersonic. So I do agree, if you use OpenVSP, you are bound to get a wrong result. That being said, you can use OpenVSP to start off, okay, to get started. I'm not saying you trust that software, but to start off, it can be a good starting point. And then, since it's a year-long competition, we expect you to gradually move on to other softwares, right? Like Professor Pant mentions open form. Since Autodesk is sponsoring this, we have CFD++ from Autodesk, right? They will be very happy to help you in this regard. But that is something you'll have to figure out for yourself, okay? The problem with open source software is that the GUI is not very user friendly, right? When you look at software like ANSYS, SimScale, they are industry-wide use. So they have a very user friendly GUI. So I would say ANSYS, but open source is also something you could look into if that helps you out. Okay. I hope that answers your question. Moving
Oh,
on, other teams,
Anybody else
uh,
has any question?
please raise your hand and I would unmute you.
There was one question in the chat window about when will there be the workshop on fusion. So the answer is that we are actually trying to talk to the people from Autodesk to set up this particular workshop. It is to be conducted by them, not by us. So we will get back to you. Team Safira has a question. Please go ahead, Team Safira. You can unmute yourself. Maybe put your video also on so that we can see who you are.
Hello, good evening all.
Yeah.
My question was like now that we have, I mean, like not we, but you have all the reports and designs. So can we know like a range of the performance score that is there?
So to answer your question, many teams have not even bothered to calculate the performance score. They have not understood what is meant by this performance score. They have completely ignored it. Okay. So we cannot tell you that, okay. And moreover, all the designs right now are in a very, very initial stage. This is a midterm report. So in the midterm report, we don't expect final results. We only want to ensure that there is good progress and you are on the right track. So we don't have the value of the performance, vehicle performance score for all the teams. Because as I said, many teams have not even bothered to calculate it.
And then also like a related question will be on in I think previous webinar it was said that this score will be carried forwarded to in the next round also. So what is the score for like our submission?
No, no. Midterm report is not going to be evaluated numerically. Midterm report was evaluated purely on the basis of go, no go. If the evaluation committee said that having spent so much time, if the students do not have any clarity on the problem, if they are going in the wrong direction, some teams have just given some copy paste from Chat GPT, etc. in the report. Those were non-serious teams. So we use this midterm report to weed them out. Okay. So we have not done any numerical calculation of score for each team, and your information is not correct.
Oh,
Nothing from this particular evaluation is going to be in the final round. This is just a midterm review. Has a particular team put in enough effort right now? Are they on the right track? Do they understand the problem? If we feel that they have not understood the problem, if they are not really working, we just remove them.
oh, okay. So also, like we would like to get a clarity on the tasks of the final design report. So there are, I think, 5 tasks are there. So if we can get some
But
clarity on this.
but there is a detailed problem statement which contains exactly what is to be done. So just follow that.
No, like in that, the fourth point is there. Like we have to take, like we have to make a graph between, or like a sketch between the, uh, like the RCS and drag of the aircraft. So how exactly do we do? Because for that, like there will be many configurations. Like how, like what is the exact thing that is being asked in that?
Sir, can I take this question?
Yeah, go ahead.
Yes. So, Team Safira, with regards to all the tasks that were assigned, I thought they were pretty self-explanatory. And by the time of your final design report submission, we expect that you would have narrowed down your configuration, okay, and you would have a single design that you will be pitching. Like midterm review is something where you might, be thinking in different directions. You could have 2 or 3 configurations in your mind and you are pitching them. You are yet to analyze them in great detail. But at the time of the final report submission, you can't be in a position where you are pitching 2 or 3 designs to us. Okay. We expect you to pitch one design and you have sized it, analyzed it thoroughly. For that, if you're asking how do you do the RCS, then I think you might have to look at literature and more books because many teams have already started with their RCS calculation. Okay, does that answer your question?
No, I was actually asking like when let me just open the report. Sorry, not report. The problem statement.
That will take you some time. I think in the meantime, we can go on to other people.
Yeah, sure.
Other people, please, you could, there is one question in the chat box. Sir, teams who have been disqualified, will they be allowed for the workshop? This is a question from Kanak Mittal. Professor Pant, over to you.
I've already answered the question. I have said no. Teams which are disqualified or not continuing further, they have no further role in the competition. They will not be getting any other training. Dhruv has a question. Dhruv, please raise your hand. Dhruv, first of all, I'm not happy. I had asked you to rename yourself. So I will ask you to rename yourself. I would like you to put your team name and bracket में Dhruv.
I'm extremely
Can you
sorry for
rename yourself?
rename it. Yes,
Yeah.
sir. Just give me a minute. I'll rename it. Come back. Just give me a second, sir.
Yeah.
Other members, other people.
Anybody else would like to have ask any question on the chat window? There is some question, I think.
Yes.
So we are having problem in calculating RCS. How to do that? Well, the calculation of RCS, there is a standard procedure available in textbooks. If you spend time and look for the procedures, and many teams have already done that. Pranav, would you like to add something?
Right. So with regards to RCS calculation, now this is something that does not come in your traditional aircraft design. And understandably, some teams are facing problems. So I'm not going to name textbooks, but at the beginning of this competition, Professor Pant had shared a detailed list of resources, and I had also shared some resources on the WhatsApp group. If you find in those textbooks, you will find a section on RCS. If not, there are detailed literature, there are detailed papers or reports which tell you how to calculate RCS. See, RCS is a complete game of the surface area. If you have the surface area, you can calculate the drag. Okay, I'm not going to divulge more than that. Okay, the rest I would request you to figure out yourself. And if there is a particular question, very specific, you can put in the chat box or in the WhatsApp or our mail. We would be happy to answer that. But if you're asking in general, how does RCS work? I think I have answered more than enough. Right.
So
Team,
team the Abhiyantriks, is that Dhruv?
Yes, sir. It's me.
So you have to put your name in the bracket na, at the end of the team.
Extremely sorry, sir. Actually, the name was getting extremely long there itself.
Remove the word
go
the.
ahead.
Okay, sir. Should I come back again?
Yeah,
Okay,
please.
sir.
We don't want people to not follow simple instructions.
Right. Anyone else, please raise your hand. We would be taking questions because we are already coming to our scheduled end time. We had scheduled till 8 p.m. It is 7:56. So we request you guys to ask your questions right now. If not, then we can close this webinar. Also, one more point. People are saying that we need a workshop on fusion and other workshops. So you need to be a bit more specific. So when we go to our partners and we ask them to conduct the workshop, we need to be a bit more specific on what they should cover in that topic. Right? If you're talking about fusion, fusion is a very vast domain. What exactly do you need? Do you need help with, making the fuselage, with, making the wings, analysis part of fusion? What exactly do you need help with? That is something that should come from you. And we really want you guys to use the WhatsApp group and email, more preferably the WhatsApp group, so that, everyone can be on the same page, so that we can conduct it in a much better fashion. Maybe we could ask for the simulation part in fusion. So, okay, you have given a suggestion. We have to put in a poll. If it is just for Team Vajra, I don't think it would make sense to do it. But if majority of
But
the
even
teams say,
simulation, what simulation? What
right,
simulation? Simulation is a big word. Anyway, let us go to team Abhyantrik. I think Dhruv has renamed himself. Let us give him the stage to ask his question. And then we come to team Safira again.
So, first of all, apologies, sir, for this misconception right now. So, actually, I had two doubts. First of all, was since you are given the payload we weren't given the dimensions for payload. Since we are starting the fuselage sizing and sizing of the complete aircraft, so can you give us an estimate time at which will you provide the dimensions for that? And secondly, the question was regarding the avionics system. So is there a certain limit we should put for the volume of avionics system, or is it up to us to give the volume for that?
Okay, so as regards the dimensions of the payload, you will require that information when you go for the detailed design. Right now, teams are still struggling with the initial sizing and the constraint analysis, but we have no problem in giving you information, but it is going to only confuse you. I don't see right now when you are still in the area of sizing, how will the dimension of the payload really make a change? Because you are not going to go for the detailed fuselage geometry calculation as yet. Okay, it will come little bit later. So we have no problem. See, we have to go and ask our original problem provider, and we will ask them to give us the dimension of we will give it to you. I don't know what you will do with it at this stage, but we will give it to you. Okay. The other thing that you asked, what was the other thing that you asked? Sorry.
It was regarding the volume we should allocate for the avionics system. Is it up to us or it will be given by you, sir?
You have to identify which avionic equipment you are going to install that will be required by the function of this aircraft. And then if you decide the list of equipment, you will automatically you will get how much volume is needed to put them. So we are not going to go and give you any volume of the payload because we have not been given that by the user agency.
Thank you, sir. Thank you so much.
Team Safira, please go ahead.
Yes, sir. So as I see in the problem statement, the F4 point is RCS calculation of the vehicle versus the drag produced and selection of the optimum point. So we are a bit confused in this. So we have finalized our design, like overall configuration. So what more do we do in this to make this plot? Like, should we play with the sweep area or what?
Exactly. That is exactly what you should do. See, you have finalized the design. I am not sure whether you have taken Akriti's suggestions into consideration that you must do a detailed sensitivity analysis to find out which particular combination is giving us the highest value of the objective function of vehicle performance score. So that is why we are suggesting that you plot this graph and have a look at, because you know that the variation of RCS is going to along the length. I mean, the RCS variation is going to make the aircraft better, isn't it? Although we have not given any specific requirement on how much should be the minimum, maximum RCS of the aircraft. Okay, we didn't want to go into that much detail, but RCS is an important parameter in detectability of a supersonic aircraft or any aircraft that matter for combat purposes. So it is a good idea to do it to get an idea about your own aircraft in more detail. And we will also go through that particular point and revert back to you on the WhatsApp group in more detail. Okay.
Okay,
What
thank
will
you.
also be nice is if you can, what is also nice if you can send us an email asking the specific question so that we don't forget it.
Yes, because Team Safira, regarding RCS, I think I have said that previously as well. If you have your final configuration ready, there is a standard procedure on how to calculate RCS. Okay, one of the professor at IIT Bombay, he has a very detailed report on how to calculate RCS. Okay, now if you have that, then I don't think where exactly is your team facing an issue.
Okay,
No,
Okay, if
it's
they
okay. Let them send a mail explaining exactly what their problem is, and then we will answer it. In this webinar, we don't have time to go into very specific things. In between Team Stealth, Glenn has raised the hand
thank you, sir.
from Team Stealth. Glenn, go ahead, please.
Okay, so I have a question on. Sorry for not turning on my camera because I'm in the jack. So
That's okay. That's
my,
okay.
my
It's your
question.
wish.
Okay, thanks. My question is on the power plant selection. So I realized that for the engines that we're looking at, most of them, if we look at their weight and compare them to the gross weight we got, there is somewhat disproportionate. So is it advisable to draft our own engines, or we're supposed to stick to an engine that already exists?
No, I think you should go for an existing engine because it will be very impractical if you also start designing an engine. Okay. So initially you might do what is called as rubber engine sizing, where you try to arrive at the approximate thrust to weight ratio required. But then you have to identify an engine that meets your requirement of the thrust and the SFC. And then you have to say, okay, we are designing around this engine, because otherwise it will be too arbitrary. So initially, yes, you can go for rubber engine to identify the required parameters. But after that, you have to find an engine which is nearby, maybe slightly more thrust than what you need, and maybe better SFC or similar SFC than what you have calculated. If you cannot find an engine, then you have to rerun the calculations with this new engine that you finally choose. So we recommend that in the end, you should have a fixed engine that you mentioned. Maybe one engine, maybe two engines, that is up to you. Or maybe more engines.
Okay, thank you.
Okay, anybody else would like to ask anything? Pranav, if there are no more questions, I think we can stop the webinar because already we are above the time limit.
All right. I just have one question from the teams. Guys, going through your reports and all, do you find this problem statement to be challenging? That is first part of my question. Second part of my question is, are you having fun working on the problem statement? These are my two questions. I really want maximum number of teams to just answer this question, and then I think we can break off. Okay, because some feedback is really important for us as well.
So they can give a thumbs up or a thumbs down.
So that just means that only 4 teams, 5, 7, 6. Challenging part was the total time of the mission to be under 1 hour.
But
Okay,
is it 1 hour or is it 2 hours?
it's 1 hour, 30 minutes going and 30 minutes back. Okay, so I am assuming only 7 people are enjoying the problem statement then. So then my
Oh, but did
question
you
has
get
been
any?
changed.
Did you see any response? Because I could not see any thumbs up in my
I
window.
saw there were 7 thumbs up
Okay.
out of 25 participants. There were 7 maximum. So I would say that is 25% of it. There were 28 earlier. I think some have left. So that means only 25% of the people are finding the problem statement challenging and having fun with it.
Yeah, for the remaining, it is a cakewalk.
Yeah, evaluations do not seem so that way.
No, that is what you feel, but they feel there's no challenge. They feel that it is a very straightforward problem. You can just copy paste from any textbook like Raymer and do it. Or they are not responding. They are not responding at all.
Right. I think,
Okay, if there is nothing else, we can stop the meeting then.
yes, I would just like to close the YouTube stream. So I would just thank you so much for attending. And if there are any further questions or queries, we are open on our WhatsApp group. We have a dedicated group. Emails. One humble request to all of you. Please don't send us personal messages which have generic texts. Don't ask questions. What is the submission deadline on a personal text? Okay, we are not going to respond. It is not that we don't get your messages. I get all of your messages. I on purpose don't respond to it. Okay, because we have strict instructions not to engage on a personal chat when it is not sensitive. If you are asking a very sensitive question, with regards to your team, then yes, we would entertain. But if it is very generic, then please stick to the WhatsApp group. Okay, I don't want to get messages on, neither does Professor Pant nor does Akriti, anyone. We don't want to get messages. Can we get a submission extension deadline? Can we submit it later? How to do this, how to do that. You have a dedicated group. Please utilize that. All right. That being said, I have ended the stream. So thank you so much.
Yeah, and
And
before we go, I also want to